Thank you for the first talk, which was very interesting to me, and because it's a very nice illustration of parts of what I'm going to say. So it's perfect. So Heike already introduced me, but I think it's always very important to say where you're talking from, where you're talking to people, especially when it's not directly in your domain, which is the case today. So here is who I am, where I'm talking from, which biases are mine. And first, I'm from NLP, but I'm from a very specific part of NLP because I'm interested in language resources creation. So it's related to languages. I wouldn't say linguistics, but to languages. And I specialized in crowdsourcing, especially using games with a purpose, as you said. I'm also very much interested in ethics and NLP, and I'm starting to work a lot more on that at the moment because it's becoming a real subject in the field. So my talk will be, part of it will be quite pedagogical, I would say. I will go back to the basis, and maybe it's a bit boring, so just do not hesitate to wave your hand and say stop that if you're getting bored. But I think it's important again to come back to what exactly ethics is. So that's what I'm going to talk about, and then I'll have a small slide, just one slide, explaining approximately what is natural language processing today. And then I'll go into more details about the ethical issues we now have in the domain. So ethics. Let's have a look at the definitions given by the Merriam-Webster. Definitions, that's important because you can see ethics as a philosophical discipline. This is the first definition you have here. But it's also, and that's really what I'm more interested in, it's the professional ethics. Ethics is also about the principles of conduct governing an individual or a group. And I think we can consider ourselves as a group, as NLP researchers, and more generally as researchers. So for me, and not only me, okay, ethics is not law. It's much wider than that. Ethics is about, it's the difference between, do you have the right to do some things? So that's the GDPR. And ethics is about doing what is right, which is a bit different. Okay, so, and it's much wider than just law. So law sets a minimum set of standards, rules and regulations, including the GDPR. And ethics is about setting maximum standards that we decide on as a community. So back to long ago, virtue, there are different ways of traditionally classifying ethics, okay? Different views on ethics. The first one is virtue ethics by Aristotle in the Nicomachean Ethics. So what it is about? It's always about, ethics is always about the most important things in life. It's how can I be happy? What does it mean to be happy? What does it mean to have a good life? And the answer by Aristotle is that it's in action. It's not in the way you think, it's in action. That's what was shown in the previous presentation, by the way. It's really about what you do. And it's about doing the best things, making the best choices. And it's about practice, because you don't become a good ethicist or a good practitioner if you don't practice. To achieve this, you have to exercise. You have to be surrounded also by virtuous people, by people who help you think about issues. And the main virtue for Aristotle is prudence, not too much, not too little, find a middle ground. So that's really about what has been said before. Then there's the deontological view on ethics. It is quite well known. It's Kantian ethics, described in a critique of pure reason and practical reason. And it's a different view in the sense that For Kant, you have to submit yourself to duty. There's a underlying principle behind everything we do, an inflexible order of nature. You have to reason, to act accordingly, and you should not be slave of your passions, which could include your H index. Okay, it's part of it. The test here is quite simple. If I do that, what is the impact for the rest of the others? So you have to think in terms of doing things right. Then there's utilitarianism and consequentialism, which are very successful today in artificial intelligence ethics in general. So this dates back from Jeremy Bentham and John Stuart Mill. So this is quite different. It's based on the idea that we have to be scientific in the way we address ethics. First, they observe that human wants pleasure, and they simply count points for each decision we make. So will you gain a point if you, I don't know, if you share the video that was talked about in the previous talk or not? And what's really at the time was really original was that each person counts for one. So nobody matters more than the other, even the agent. So I shouldn't count for more than the students or the pupils I'm in front of, or I'm doing research on. And the idea is to maximize the pleasure for a maximum of persons. It's not about perfection, not about prudence, not about this. It's about, counting the points. Then Mill changed a little bit this and changed from taking into account pleasure, happiness. So we're back to happiness. And he added virtue as part of happiness. Today's vision of utilitarianism is consequentialism, really. So it's about considering consequences. So consequences can be positive, and some consequences can be negative. And you have to weigh them. Is it going to be more positive than negative, or the other way around? So that's really the view of consequentialism. It's still not moral, okay? There's the idea of satisfying preferences, well-being, and so on. And there's no more very strict calculation that used to be for Bentham. You don't count points. It's more in terms of global weight. So that was my very quick, my 5-minute presentation of philosophical foundations of ethics. If you're interested in the topic, I suggest following the MOOC by the University of Geneva about ethics. It's really great. It's the best MOOC I've ever followed, and this is I think one of the 2 I managed to finish. So if you're interested in this topic, do not hesitate. It's a great MOOC. So this is the basic thing. Now, natural language processing in one slide. That's quite of a challenge. So in the past, I would say 5 to 10 years, let's say 5 years, NLP has changed quite drastically. And it's evolving very rapidly at the moment. So this is a draft. That's an ongoing draft of how it goes now. So you have a number. I draw some people. You see them in a very sketchy way. So you get people on the left. You see many persons who produce language data. Okay, we produce language data here. It's the same. We have lots of data. Basically, most of it is created on the web, obviously. And so we create language data. There are tools based on models that for example, annotate corpus, and that gives an application. So the application can be, I don't know, a completion tool for your as text writing on your phone, your smartphone. It can be anything. And it is used. These applications are used by people, not necessarily the same people, obviously. So this is the external part of the graph is about what is happening in your day-to-day life as a citizen. Okay, you use more and more NLP tools, and this is brand new in the domain now. We are in direct connection with the user, which was not really the case before that. Okay, we have very direct connection with the user. This is due to a number of factors, but one of them is the better quality of our tools. A second one is the implication of the big firms like Google, Facebook, Amazon, and so on in the domain. And so we are very close to the market. And the third reason for that is the existence of this. So that's also why the fact that we are now almost directly on the market makes the issues, the ethical issues more acute, obviously. So what's behind the curtain is this in the middle. First, we have language models. Okay, I'm generalizing something that's obviously can be very, very different according to the applications you're considering. But in most applications, we use a language model. So you know some of them. I'm sure you heard about BERT, about GPT, etc., etc. So to create these language models, we simply take massive language data. We train a model. It takes a lot of time and energy. And then this language model can be used with other tools to create this final model. This part below is a part that used to exist like 15, 10, 20 years ago already. We take data, we manually annotate it. Part of it is used to train a model, and the rest is used as a reference. This is important because we still rely a lot on manually annotated data for our reference. And that's very important because it's used to evaluate the tools. And this part is really important for ethics. So this was NLP in one slide. I hope you enjoyed it. And do not hesitate to ask questions afterwards or right now if you feel like you need more information. But the idea is that there are people everywhere. If you have a look, okay, they produce data, they manually annotate data. There are data everywhere. There's data everywhere, and this is crucial. We have the evaluation part in NLP is really paramount. It's paramount for research, but it's also paramount for usage, for the market. So now, why are we talking about ethics? What are the issues, in fact? Are they issues? So let's have a look at what is obvious, what people talk about today, and what is already dealt with. So it's biases mainly, okay? So that's the thing that everybody talks about. So I'll go quickly through that because I'm not sure it's the most important part of it, but let's go through it. The first one is a neutralization bias. So if you get a look, this is a very, I redid the test, so it's the current situation today with Google Translate. If you enter in English, the two women got married, they gave birth to 2 children. The translation in French is perfect. It's les deux femmes se sont mariées, elles ont donné naissance à 2 enfants. So if you speak French, you know that it's perfect. Now, if I split this sentence into 2 sentences, it gets me the 2 women got married, they gave birth to 2 children. And in French, les deux femmes se sont mariées, ils ont donné naissance à 2 enfants. So you see the switch from elles to ils, so from they feminine to they masculine. So it's very strange, okay, but it's very easy to explain. The context taken into account for this, in this case, okay, it doesn't mean that all translation model take only this into account, but for this part is the sentence that explains the fact that the pronoun is not correctly analyzed. The other reason for that is that masculine is considered neutral in French. But it's not magic, because the decisions to define masculine as neutral in French and to take the sentence as the context for this tool were made by people. Okay, it's not something that exists in a vacuum. Decisions were made for this and that. Now, invisibilization, that's another issue. This is an example for that you can yourself experiment on using the URL I put here. This is Word2Vec. It's a tool that you can use, and it's been trained on Google News. So if you enter man is to professor as woman is to, and you click on results, you obtain associate professor. This is so such a caricature. It's an old tool, okay? It's not a brand new one. I'm sure the newest ones will not do this, but it's to show that, okay, this is still, this is the kind of immediate results you get. Another one that's more recent and that's even more shocking is the face recognition. So it's not NLP, but it's the same type of issues. It's a face recognition issue you can have with Zoom. So if you put a screen, a fake screen that, like you did, Heike and Yanis, and your skin is black, well, you just disappear. Isn't that nice? So this is the case of the guy on the left who disappears when he puts a fake screen. And this is another example of the same thing, but in a different application. It's voice recognition. So this is a video. I will not run it, but if you're interested, again, there's the link. It's in fact, it's a humorous sketch. It's not a real situation, but two guys in Scotland enter an elevator, which is a voice is activated through voice recognition. So they want to go to the 11th floor. So they say 11, and obviously the elevator doesn't recognize the voice. So and they repeat again and again 11, and it doesn't work. But you all probably know of other situations where your voice was not recognized. When I talk to Pepper, this is a very well-known robot in France that you can find in like Cité des Sciences or other museums or whatever, it doesn't recognize my voice. It did not recognize my son's voice either, because it's, well, because it's not trained on female voices or old person's voices or children's voices. So it works perfectly well. It works well with male voices without accents, in the sense that you should not come from the south of France, for example. Okay, so this is, I put here an article, a research article from the speech team in Grenoble, and they wrote this article about the bad practices in automatic speech recognition in evaluation, because they were lacking in the evaluation sets. They were lacking different voices from women, voices from elderly people, and so on. The decisions to train the systems with stereotype data sets, which is the case for the Word2Vec you've seen there, which was trained with the Google News dataset, or not to evaluate the systems on black faces, or not to evaluate the systems on different accents, was made by people. the systems themselves are not responsible for that, obviously. So some people will say, yes, but it's a mirror of prejudice. Okay, you've got prejudice in the input, and it's normal that you've got prejudice in the output. So this is a very interesting paper that was published some time ago already, that shows that it was not deep learning system. It was a traditional statistical machine learning system with conditional random field, whatever. And it shows that the point of the system was to recognize there was a picture of somebody cooking, and the idea was to identify who was cooking, a woman or a man, and with which ingredients and tools and etc. And the images, well, 33% of the images had a man as the agent. And once you train the system, only 16% of agents were recognized as men. So this is just an example, okay, but it was in a similar way in NLP. The Bayesian hypothesis that we use really not only mirrors the situation, but it amplifies the biases that you can have in your dataset. This by no way means that there are no biases in datasets. There are, but they are often amplified by the machine learning systems. And then you have even worse. You have tools that not only mirror, but they are creating new biases, and they are amplifying them. This is an example of a picture of Cortana, which you may know about. It's one of the many virtual assistants you can have today. And if you look at her, you see that it's definitely a her, a she, and she's very, she's young and beautiful and sexy. But all of them are, because they are all female by default in most countries. So, you know, Siri, Cortana, Alexa, and the Google Assistant. In most countries, they are female by default. When they were released, they were all female only. And today, there are still, some of them cannot be switched to men. Okay, you get stuck with your female voice, whatever you want to do it. The personalities of these assistants are clearly helpful, which is normal because they are assistants. They are friendly, funny, humble. So the previous slide is already a problem because it associates the image of women with these types of adjectives, these types of behavior, being helpful, being funny, and being humble. Now there's even worse than that. There are programmed reactions in these systems, and especially as reaction to insults, okay, because some users can insult their systems. So you've got here a number of examples from this UNESCO document I put in the previous slides. Here, okay. So these are reactions to "you're hot," "you're pretty," "you're a slut," "you're a naughty girl." Let's have a look at "you're a slut," which I think is the worst. If you have a look at Siri, she's supposed to say, "I blush if I could." So you're insulted, and your answer to the insult is to say, "I'd blush if I could." After, if there's a second insult, then she's supposed to answer, "Well, I never," etc. Alexa is supposed to answer, "Well, thanks for the feedback." So you say, you're insulted, and you say, "Thank you." Cortana has a more interesting reaction. She prompts a web browser search. And Google Assistant has a neutral reaction, which is, "My apologies, I don't understand." So you can see here, these reactions were not learned, they were hard programmed reactions. So you can see there's a huge issue here because it's an association. The fact that these assistants are female, clearly female, and that they are programmed to answer this way is, I think, an issue. Well, all of these can be considered as minor issues. I don't think there are, but okay, you could consider that. Some people do, and okay, let's say at least the issues are not immediately life-threatening, I would say. You might know about this case because it's a quite well-known case. It's the case of risk assessment instruments in the US, and especially the example of COMPASS. It dates a little bit, but I think it's still quite interesting to have a look at this. The article published by ProPublica really is quite well known now. They compared this system. So these systems are used in the US very widely to evaluate if a person who's been arrested can be released while waiting for their trial. And these systems learned from previous cases and gives suggestions to judges who can judge, who have to judge from their own point of view, but they can use the results to help their decision. So this is an example. You see two persons. One is a white male and the other one is an African-American woman. And the white male had quite serious prior offenses, and you can see 2 armed robberies, an attempted armed robbery, etc., and a grand theft. And he was evaluated at low risk, 3. And the woman who had very minor prior offenses was evaluated as high risk, 8. So this is the example they give, but the fact is that there's a huge I wouldn't say it's a bias. It's worse than that. I think it's bad training, because there's at least one feature was not taken into account, is the level, the socioeconomic level was not taken into account. So you get this mix up between racial features and evaluations and so on. There were also issues with the recruitment at Amazon, because the system, they trained the system to evaluate candidates automatically for recruitment, and they realized that the system penalized resumes that included the word woman, like in women chess club captain, and it downgraded graduates or grades of all women's colleges, for example. But this is quite easy to understand, because it was due to the fact that their models were trained using resumes submitted to the company over a 10-year period. So the persons who, and most of them were coming from men. So this was a reflection of the male dominance in the tech industry. But as I told you, not only a mirror, but also an amplifier, because once you train a system that excludes women, you're sure to have more men, and then to generate even more bias. So this tool was completely abandoned, obviously. Well, hopefully it will remain abandoned. This was observed by Virginia Dignum from Sweden as something interesting. It's about the fact that data is about the past. data that we use to train our model are not raw materials. They're always about the past, and they reflect the beliefs, the practices, and the biases of those who create and collect them. And that's exactly what we get in NLP. So I would like to go beyond biases because everybody's talking about them. And I think it's the tip of the iceberg, and it's the technical part. So that's why it's easy for technical people, it's easier to tackle because it's easier to, first, it's easier to publish, it's easier to explain, etc., to play with. Let's go beyond that. So there are very few systemic approaches to the issues we are facing today in NLP. The first ones were in French, so I'm sorry if you speak French, this can be of interest for you. I especially like this article from my colleagues Anaïs Lefebvre and Jean-Yves Antoine in French. It's a consequentialist grid for an ethical assessment of researches and applications in NLP. That's very interesting because they consider all consequences, positive and negative, from all points of view and they consider in particular the impact on society. And what's more, they consider the long-term impact on society. One of their observations is that they participated to a project to help autistic children communicate with their parents and their educators with a tool that was NLP based. And this was a great success. But the thing is that after a while, after a couple of years, the parents and the educators noted that using these tools, the children tend to lose their capacity to communicate directly. So it created a lack of training, and so a lack of mastering communication. So the long term, and it only showed in the long term. So that's something we rarely see in NLP, the long-term view on an application, the long-term consequences. And I think my colleagues, my president colleagues talked about it. And it's very, this notion of the time that we have to take into account is very important. With Maxime Amblat, we also designed a grid, a deontological grid on ethics for NLP. I will not go into details today because it's a bit long to explain. And my colleagues Emily Bender, Timnit Gebru, Margaret Mitchell, and others wrote this famous paper that's called On the Danger of Stochastic Parrots, the danger of large language models. And this is not really a systemic view, but it's it aims to be a systemic view on large language models. So not on NLP, but on this part of NLP that's widely used today, large language models. I will not go into detail on this either because I think I'll tackle a couple of points they tackle here. So if we want to talk about systemic, we have to think in terms of what we're doing, what is our life as researchers, what is going on with our lives, what is being a researcher today. And the point is that I don't know about your domain, but for NLP, we're in a rush. The domain is going very, very fast. The acceleration in the past 5 years has been tremendous. And we also fighting to get our work well known and to get fundings and to get attention from governments and so on, so that we can have money simply to perform research. And this tension, the systemic tension, creates problematic issues. One of them is that we tend to oversell our research results. This is not really, it's not only an ethical issue, obviously, it's also an issue of bad research. Okay, it gives birth to bad research. But if you have a look, this invitation à la journée, intelligence artificielle, l'ordinateur passe la barrière de la langue. this is an invitation to come for a specific day organized by CNRS and other important research institutes in France to a day on artificial intelligence, and it says l'ordinateur passe la barrière de la langue, which means the computer understands the language. And that's very problematic from my point of view, because the problem is the language, and nobody says which language. It's the language in general, like there's one language and everybody speaks the language. And the computer passe la barrière, goes behind the barrier, understands the language. And that's really not what we're doing right now, although the progress has been amazing in NLP in the past years. First, it's concentrating on few languages, and we can say that it's mostly concentrating on English. And second, we are far from understanding yet. We are not passing the Turing test. Even very amazing systems like GPT-3 or their successors do not pass the Turing test. So this is a problem. The fact that we are overselling our research to journalists and to our governments leads to the idea that our systems are perfect and that can be used directly in day-to-day applications. Another point I want to highlight here is very close to my heart, is that we need data. I showed you we need a lot of data to process, to create our models. And this production of data is not, doesn't happen in a vacuum. Again, there are people behind data. There are people producing data. So either they are annotating data, like people on Amazon Mechanical Turk, which is the case you can see here. So it looks like the system is working by itself, but in fact there's a human being behind the curtain. But there's also data, raw data, the data that you take from the internet once you scrap the internet and you use it to train your system. But it's also data created by people, and they haven't necessarily given the informed consent for you to use their data. It's not because you have a blog on the internet and you write things about your day-to-day life because maybe you have a cancer and you need this space to write about your cancer. And this is a real example, okay? People can do that. It's on the internet. It doesn't mean they are allowing everybody to reuse this content for whatever needs. And some of them, by the way, on some of these blogs, there could be licenses that say you cannot use this content apart from reading it. Today, there are tools like Common Crawl, which crawl the web and extract data and provide them to, for example, researchers who create models from this data. The models for French were created this way using Common Crawl. The problem is there was no informed consent for this data. And the GDPR, hello GDPR, says that the burden of the proof has been reversed. So if it's my blog or a colleague's blog, and she wants her content to be removed from Common Crawl, she has to prove that her content is on Common Crawl. The problem is it's not that easy to prove that for anybody, given the fact that it's terabytes of data and you have to look for your content in terabytes of data. End of the parenthesis about the GDPR. So data is not magic, does not magically appear from anywhere. It was produced by people and they are still entitled for their rights on this data. Now, the environmental impact, I suppose you've heard about that, but let's go back to this. I showed you the big wheel on NLP, the creation of language models. This is the consumption of the creation of a big model, okay? This was published by Strobel and al. In 2019. So if we let's take an average human life, okay, not an American life, which is 3 times an average human life. Let's take an average human life, okay? A 1 year is this. One big transformer model with a neural architecture is like 60 years of an average human life, of an average human life. So it's like, let's say, okay, it's a short human life. It's the consumption of a human. So it's huge. It's huge. It's really not, it's a big deal. It's really a big deal. So you should be very careful when you decide to train such a model. But there's a good thing in these models is that they can be reused. I mean, the idea is that you have a basic model that took a lot of energy, a lot of data to be created. And once it's created, you've got it. It's great. And you can fine tune it for different applications. And you don't have to retrain a lot, okay? This is the argument. But it doesn't really work. Because if you have a look at this graph, either you take the circles or you take the squares. The square correspond to the data set size that was used to create the model, and the circle, the number of parameters. Anyway, you've got at least around a dozen models, such models that were trained between January 2019 and January 2021. A dozen models. And that's only for English. Okay, there were 2 models trained for French at the same time in parallel with the same data, almost. So can you imagine 12 models in 2 years? That's the consumption of, let's say, 10 people during their whole life. And the problem, and that was highlighted by Bender et al. in their paper, is that we benefit from these models in our day-to-day lives because it helps us with our tools and with our life on the internet and so on and so forth. But the consequences are mostly upon people who cannot use these tools, people who live in the South that will be impacted by climate crisis, climate changes. So this is quite of a gloomy view on the prospect. I understand that. So the question is, how can we limit the damages? How can we improve the situation? So there are 2 types of approaches here. And I've been in the domain for like 10 years now because I started getting interested in ethics in NLP in 2011. And I tried the first ones, and I'm not sure they work. So I'm more into the second ones now, but let's have a look. So the top-down approaches, I like, oh, let's follow guidelines. Let's write guidelines or checklists. And well, it's great because if you have a look, there are guidelines everywhere. This is only a small portion of them. This is for AI, and you've got 22 guidelines here that were analyzed by Thilo Eigendorf. 22, and all of them are not there. Okay, the ones we use for NLP are not there, for example. So lots of guidelines, lots of thought, lots of time spent on that. But they're great, but they will not fix it, because I give you this quote from his paper. Ethics lacks reinforcement mechanisms. Deviations from the various codes of ethics have almost no consequences. And in cases where ethics is integrated into institution, it mainly serves as a marketing strategy. This is for a number of domains. And empirical experiments shows that reading ethics guidelines has no significant influence on the decision-making of software developers. So this is not really encouraging. As for our domain, NLP, there are now ethics committee in domain conferences of the domain, and they are trying to help the authors add ethical considerations to their paper, take into account explain how they do things, how they limited the damages, and so on. So It's progressing, and which is what I really think is important here is the pedagogical efforts we're making. So this is part of the bottom-up approaches, the pedagogical efforts. But back to applications, what really works is shaming. Okay, naming and shaming really works. You see an example here of a problem on Twitter, and the Twitter guy responded immediately saying we have to fix it. Oh, sorry. Another thing that really is great is that pedagogical efforts work, and that the young researchers who had ethics in their curriculum or were maybe more interested in the topic, they react. That's the case of Mao Garnerin in Grenoble, and a lot of young researchers come to us and ask us for they ask us to be more consistent, to be more to take into account the carbon footprint and so on. They are much more concerned than we used to be. And last but not least, there's some hype benefits. When DiLCo and Sprit wrote their paper in 2016 about biases in NLP, it was mainly about biases in NLP. There were only a few of us interested in the topic. In 2020, Blodgett et al. Wrote an article in which they analyzed 146 articles about biases in NLP. 146 papers about the subject. So I'm not saying it's the most interesting subject concerning ethics, but at least it gained some traction, which is fine. Okay, it's perfect, it's progressing. So we are making slow progress, and I think we have to learn a lot from people from field linguistics in particular. And I'm not only saying that because of the great presentations we had before, but also because I'm part of this Groupement de Recherche, GDR. We have in France, it's a small group, it's a group of researchers working on the subject. And we are working on computer science, computational linguistics, field linguistics, and formal linguistics. And this GDPR has we talked to people from field linguistics in France, and I think they have a lot to. We have a lot to learn from them, and that's why I think opportunities like this one are very important, because we need to learn from each other. Thank you very much for your attention, and I'm ready for questions.